This video is for your interactive notebook foldable on one-step equations. Hey everybody, so as you know, I'm not here. So what we're going to do is I'm going to walk you through how to do this foldable for one-step equations. Okay, so first what you're going to do is grab some scissors and cut around. Doesn't matter which side you pick, cut around the outside edge. Alright, so hit pause and cut around the outside edge. Okay, so now, you have a paper that looks like this. Hold it so that way you are looking at the part that says the subtraction. Alright? You're folding it on this line. So fold it on the line. Okay. So you should have a piece that looks like this. The 4 words on one side, the long blank side on the other. You are going to glue this part down so it's going to look like this in your folder. You can do it long ways if you like. You could do it long. You know what? Do it long ways across two pages, or what you can do is you can slice it in half like this. Okay, just like that. So addition and subtraction on one piece, multiplication, division on the other, and you'll glue them into your notebook like this. So these words flap up. Okay, so that's what you're going to do. Glue those in now. Okay, so you could have had them glued down like this, so notice how they're straight across. Alright, I just spanned it over 2 pages, or what you could do is, I'm going to flip the page and show you. You could glue them down like this. So you have the addition and subtraction up top, and then the multiplication and division on the bottom. Okay, and then once you glue those down, the next screen will show you, and we will actually go through what to write on the inside of these piece by piece. Okay, so what we're really working on for this interactive notebook foldable is solving one-step equations. And when solving one-step equations, our goal is to isolate the variable, better known as getting the variable alone. Write that down somewhere in the bottom of your notebook or somewhere on there, that the goal is to isolate the variable, getting the variable by itself. So let's look at the addition subtraction tabs first. So your addition and subtraction tabs were going to look like this. This is what the front is going to look like. And if you feel so inclined, you're more than welcome to color in the little addition thing and make it pretty if you want to. If you don't want to, that's fine as well. If you just want to highlight the entire tab, whatever. I don't really care. Okay? So we're going to be working here with the addition and subtraction tab first. And when you open it up, you should have something that looks like this. Alright, let me bring this to the front. Okay. Alright, so when we look at the addition side, so when you flip up the addition tab, it says that we need to subtract the constant from both sides of the equal sign. And what that means is we have this equation here, and it looks like x plus 3 equals 7. Well, remember, our goal is to isolate the variable. So we're going to use those inverse operations that we just did a whole interactive notebook piece on. Okay? And I'm sure this will bring back some memories from last year's. I'm going to draw some railroad tracks. And what I'm going to do is I'm going to look at the side that has the variable. And I'm going to start there because I need to get that variable by itself. and I can see that I have x plus 3. Well, I need to get rid of this plus 3. So I'm going to use the inverse operation of a positive 3, and I'm going to subtract 3. And what I do to one side of my equation, I must do to the other. So if I subtract 3 on my left side, then I must also subtract 3 from my right side. So I'm going to subtract 3 over here. Now, super important, every student forgets, I don't know why they forget, but they forget. Draw this line, okay? That line signifies that you're doing a math operation of some sort. So as we look at this, we look at the left side first. Our left side, we have positive 3 minus 3. Positive 3 minus 3 will cancel out and end up giving us 0. So I'm left with x plus 0 equals, if I look at the right side of my equation, I have 7 minus 3. 7 minus 3 is 4. Okay? X plus 0, whenever you add 0 to something, it doesn't change the value. So I can more simply just write this as x equals 4. Now, I have a value of x. I just found out that x equals a certain number, and I can check this answer. I can check this answer by moving forward. Let me slide this up a little bit, and I can plug it into my original equation and see if I'm right. So I can take this answer, and just like we did with evaluating expressions, I'm going to take this where it says x equals 4, plug it back into my equation, and let's see if I get the right answer. So if I plug 4 in for x, I get 4 plus 3 equals 7. Well, 4 plus 3 is 7. 7 does equal 7, so I know I'm correct. Okay, so let's look at a subtraction equation. So if I look over here at the subtraction equation, our directions tell us to add the constant to both sides of the equal sign. Well, looking here, my variable is x, which means that my constant is going to be this negative 5. Remember when we just talked about in the interactive notebook that when the negative sign is in front of a number, it goes with it? So that's a negative 5, okay? First thing I'm going to do is get in the habit of it is drawing these railroad tracks. Now the opposite of a negative 5 is a positive 5. So I'm going to add 5 to both sides of my equal sign. Draw the line that signifies that we are doing a math operation. Looking at the left side of my equation, I see that I have a negative 5 plus 5. That will cancel out to simply give me 0. So I could write x plus 0 equals. And then on the right side, I'm going to do 17 plus 5, which will give me 22. I don't necessarily need to write this plus 0, so I'm just going to simply write x equals 22. Now, do I think I'm right? Yeah, I'm pretty sure I'm right. But what you're going to get in the habit of doing is taking this answer when you finish, and you're going to plug in our value that we just found of x and plug it in 4x like we've been doing with evaluating expressions. And we're going to do 22 minus 5 equals 17. And we can see that as we continue on, if I do 22 minus 5, I get 17 equals 17. 17 does equal 17, so we know I'm correct. Alright, so let's take a look at, on the next slide is going to be multiplication and division. So now we've moved on to the multiplication and division tabs, and again, If you so feel inclined, you are more than welcome to color these in. It's up to you. If you want to, great. If you don't want to, I'm not going to be heartbroken over it. Okay? Do I think take a little time and make it look nice? Sure. But if coloring's not really your thing, then, like I said, not really all that worried about it. Okay. One second. So again, on this first problem, we're looking at a multiplication problem, and our step tells us that we must divide both sides of the equal sign by the coefficient. Now, let's put a little circle or a little box around this word coefficient. And what the coefficient is, and we talked about it a little bit before, and I'll give you an example of what a coefficient is. So if I have a number, and that number is sitting in front of a variable, the coefficient is this number that sits in front of the variable. It is a number that's multiplying the variable. All right, if you would like to make that little note, coefficient, number, multiplying variable. The coefficient, that is one of those vocabulary words that you're going to hear from now until the end of high school, and if you take math in college, you're going to hear that word, so you need to get used to hearing it, okay? So, again, when we're solving a multiplication problem or multiplication equation, we're going to divide both sides of the equal sign by the coefficient. So let's take a look at the example that we're given. Okay. So the equation reads 4x equals 12. Well, what we're going to do first is we are going to draw, can't see that color? Draw those railroad tracks down the equal sign. And our direction says to divide both sides. Now we know that this problem really means 4 times x. Okay? Really means 4 times x equals 12. Well, in order to undo multiplication, we must divide. So we're going to divide both sides by our coefficient. In this problem, our coefficient is 4. And here we're going to label division like a fraction. So we're going to divide both sides by 4. When that happens, 4 over 4 becomes, we look at that as a fraction, and we know that any number over itself simply equals 1. So that's going to cancel out, and we're going to get x equals 12 divided by 4. We read this like this, 12 divided by 4 equals 3. So we got a value of our x, and our value that we got was x equals 3. And again, we can check that answer. So we're going to plug that back into our equation, and we can do 4 times 3 equals 12. And now you can ask yourself, well, does 4 times 3 equal 12? If we do the math, we get 12 equals 12. So the answer is yes. Okay, let's look at the division problem. So for division, so for this division problem, the step tells us to multiply both sides of the equal sign by the denominator. Another huge vocabulary word here, which you should know. The denominator is the bottom number of a fraction. Okay? So as an example, if I have x over 6, the 6 is going to be our denominator. Okay? Let's take a look at the problem. Again, our step is to multiply both sides of the equal sign by the denominator. Scroll this up just a little bit more. First thing I'm going to do, draw those railroad tracks. Now we have to multiply both sides by our denominator. Our denominator here is 5. So that means I'm going to multiply by 5 on this side. And then I'm going to multiply by 5 on that side. Still draw that line, so make sure that you know you're doing that step. These two 5s are going to cancel each other out because inverse operations cancel each other out. And notice that I'm just going to be left with that x, and that's going to come straight down. So I'm going to get x equals 5 times 5, which is 25. If I wanted you to check your answer, you most certainly can. You're going to take this value and plug it back in for your variable, and you would get 25 over 5 equals 5. Well, 25 over 5, that's a division problem. 25 divided by 5 equals 5. So you get 5 equals 5, which is correct. All right. Make sure that you have all these notes on. All these notes that we have done in this video on the foldables, and the foldables are put inside your notebooks. I will be checking for those tomorrow. And don't worry if you don't understand it now. That is okay, because we will be going over this. This is just the introduction. All right? Have a great day. I will see you tomorrow.